What's up, you guys? I'm going to go over a little bit more about domains of functions and how to kind of properly investigate, the elements of these functions, how to look at them from a wider aspect without doing too much to them, so you can understand exactly what you're looking at, and then kind of again enlighten on the pitfalls that I see and the mistakes, and try to thaw out those discrepancies and nuances and to help you better understand what you're looking at most of the time. So I'm gonna start off with the function. Of course, we always start out with the function. Oh man, oh there it goes. Okay, so y equals to, let me see, I have it written down, x cubed, and this one I pulled out of a calc book. Now you're probably asking, why only domains? Well, because the concept of domain in itself gives so much trouble to students that if you understand how to really kind of if you understand how to deduce the domain from a function, then you can most likely get the range also, right? And here is a really good example of understanding the domain. Now, we talked about domain in the previous video about being those x values that make this function defined. Again, those x values that make it defined, not 0 points. And that's another mistake, is that people often mistake the domain for the 0 points of the function. That's not what we're looking for. We're not looking for zeros. I don't think in pre-calculus you have to worry about that. But we are looking for the x values that make this defined. And again, it's a rational expression, so you always think rational expression, you need the denominator to be anything but 0. So a over 0, a being any number, is undefined. And it could be negative, it could be positive, right? But it just can't be 0. That means we have to set 3x squared plus 1 equal to 0. But before even doing that, before getting into the mechanics of everything, instructors like to throw these at you just to kind of psych you out, because this didn't even require work, and this is probably time saved if you understood what you were looking at. I certainly would have had trouble with this in the past, and well, hopefully I can clear this up for anybody who's watching. Check this out. We need 0 in the denominator, right? Now, is there any possible x value that you can plug in that will get you 0? Because understand that you're adding 1 to this, and then you're squaring whatever x value you plug in. So even if you were to get, or you were to evaluate the denominator's expression with a negative number, you still yield a positive number, right, after squaring it. And then you're only going to add 1 to it. So it's all reals, essentially. You can use any x value and place it into this function and still get a defined value. You're not going to get 0 in the denominator. Plug in -1, for instance. That's still going to give you the function of -1. Let's not worry about the top. Let's just say this is 1 over 3. Okay, whatever. Yeah, it will actually be -1 cubed, right? -1 squared plus 1, right? Now, -1 cubed is always just -1. And then, what do we say here? So that's just going to be 3 plus 1, right? Or -1/4. And that is a definite value. That's okay. So a lot of times this doesn't even require the work. It just, I guess, it just requires not so much intuition, but just relying on certain concepts that you've learned along the way. And even if you were to set it equal to 0, this is where students might get mistaken, and the difficulties might rise. Is go ahead and set it to 0, right? Like we always do, and then subtract 1, and then you're going to see you involved a negative now, right? So x squared divide by, now I'm going to divide by 3, right? So when we take the square root, there's an issue. What's that issue? The fact that we've involved a negative under the square root, and that's a no-no. Remember, negative numbers under the square root do not work well. They're not, at least at this level of mathematics, right? We're not dealing with that. In fact, again, I've already mentioned that later on in the course, you guys were introduced briefly to the idea of imaginary numbers, I, right? which equals to the square root of -1. The reason why this entire chapter or this entire segment is on its own is because it has no correlation to these guys. It's a whole different ball game. So this is not going to get you anywhere. And to prevent that, just look at the basic facts and what you see here and visualize exactly, well, I'm not going to be able to get 0. There's no way I'm going to get 0 with any x value that I plug in, at least on the bottom. And that being said, you can even plug in 0 and still get 1. So there you go. You're not going to be able to yield an undefined expression. So again, the domain of the function, right, is basically all reals, right, where negative infinity to infinity, right? So that's that. Let me carry on. There was another expression, right? I thought this was interesting. 1 over, oops, I'm clumsy, man. Cool. Again, rational expression. Let's set the denominator equal to 0. Like, that's not me being sloppy. My pen is messing up. It's my computer, actually. Right? So we're gonna have root x equal to 4, right? And x equal to we're gonna take the square. We're gonna square both sides, right? Reverse process 16. All right. Well, we have something here. We do. Now, understand that first of all, before even getting into this segment, going into strategy and mechanics of everything and doing all that, understand that any x value, again, any x value that you use has to be 0 or positive, right? Why? Because you're evaluating this function with the root value. Even if there was, say, an x up here, anything with an x, you can have any type of variable with an x up here, right? Still, know that the restrictions lie right here because it's a root. So know that you have to have at least something, an x that's 0 or greater, right? So your domain, and then we know that x equals to 16, right, is going to give us 0. So if I plug in 16 in there, and then we take the square root of 16, 4 minus 4 equals 0. So essentially, it's anything positive, right? And it's between 0 and 16, right? So 0, we can actually include 0, 0, and 16. Right? And give me a second. I have to answer a phone call. I'm gonna pause it. Okay, sorry, you guys. That was actually my supervisor. But so, anyways, we were talking about this. So it's between 0 and 16. Actually, not even 16. We can't even include 16 now. I think about it, because guess why? If we were to plug in 16 in there, we unfortunately would get 0 then, right? So we can approach 16. Right? And that would be essentially your domain right here, or d of f. It's not bad once you kind of put things into perspective. Right? Okay. Oh, and one other thing I want to mention is that this value, root x minus 4, right, is not root of x minus 4. And notice how I said it differently as well. This jargon and the way it's messing up on me. Okay, jargon and the way you kind of verbally say things has a big influence on how you're going to internalize everything. So root x minus 4 versus root of x minus 4, they're not equal. They're not the same thing. They have different properties. So just know that that's a common area where students tend to get really confused, you know, because I can understand why things may look alike, well, understand that these are different entities, right? Yeah, anyways, keep that in mind. One other one that I wanted to focus on, where is it at? Oh, what kind of involves what we just did. X. I found this in a calculus book. This is a root. This is a root. This is a square root right here. 4. Here, let me write it. X. It's not me being sloppy, because I promise this time, it's my computer. It's messing up. It's glitching. There you go. See? There you go. Okay, but we can troop on. All right. How do we find the values for this? Right. Well, I mentioned in the past that when you look at, say, just a function of 1 over a function with a square root in the bottom, say square root of x, right? We know that alone the square root of x, this function alone here, when not placed within as the denominator of another function, has the x. Something's happening. Man, it's getting real bad. I gotta fix my computer. X has to be greater than or equal to 0, but because it's on the denominator, we know that x has to be just greater than 0, cannot include 0. So we know that anything under the square root now has to be, it's an inequality, right? It has to be greater than 0. Now, it's really messing up. This is scaring me. So we can solve for this, right? We can actually just factor this out. 2 minus x, 2 plus x, right, greater than 0, and then solve for each. So it'll be 2 minus x greater than 0, and 2 plus x greater than 0. Again, forgive me, my computer is really messing up right now. 2 greater than x is less than 2, and x is greater than negative 2, right? So that's essentially our domain right here. So we can even put that x is less than 2 and greater than negative 2, and that is our domain for this function. Our negative infinity to negative 2 union negative 2, negative 2 to 2, and then union union 2 to infinity. Right? So if we look in the number line, we have that placed here, negative 2. Completely lost my my marker. There it goes. 2, right? And you have infinity, negative infinity. So you have all these x values going from here. Approach 2, and I explained in the previous video of how that works when you're approaching and what the domain means when you're approaching these numbers, right? Then 2, and then to infinity. Because we're not including 2. We're not including 2. Go and plug it in and see what you get, and you notice you get 0. Right? Okay, so I'm going to call it quits right here. Hopefully that put into that put into clarity these concepts just a little bit more. Yeah, and I'll continue with more stuff. Thanks.